This video is for the topic 3 quiz review. So the first question is asking us to write an equation for the inverse variation represented by the table. So remember that with inverse variation, the way that we can tell that something is inverse variation is by looking at x times y. And so for each of these, -4 times 4 is -16. -1 times -16 times +16 is -16. Half of -32 is -16. And then 2 times -8 is -16. And so that value, x times y, is the constant of variation, k. And so remember that in order to write the equation, we're taking y and setting it equal to the constant of variation. So in our case, -16 over x. So this equation represents the function by the table. It could also be that it's represented as that constant of variation, xy equals -16. Could also be a correct answer for an inverse variation because those are equivalent equations. For 2, it's talking about the graph of a parent function. So remember that when we're looking at graphs of a parent function in terms of the function 1 over x or the reciprocal function, we're comparing that in terms of a over x minus h plus k. So if it's only telling us that the graph is translated 4 units down, they're telling us that k is -4, and that the graph is translated 5 units to the left, they're telling us that h is -5. And so using the transformational function, they did not give us a value for a stretch or compression. So that means that a is 1. And so this equation would be represented by y equals 1 over x minus h plus the k. So that's going to become x plus 5. And then plus a -4, so -4 to represent that value for k. So the equation is y equals 1 over x plus 5 over 4. So this equation is y equals x plus 2 squared over x squared plus 7x plus 10. So x plus 2 squared is actually already factored. So what we need to do is factor x squared plus 7x plus 10. So in this case, our a is 1 and our c is 10. And so when we're doing our product sum table and multiplying a times c, we're multiplying 1 times 10. So 1 times 10, which gives us 10. And so we need 2 numbers that multiply to 10, but add to 7, which is our value for b. And so the factors of 10 are only 1 and 10, or 2 and 5. And so 2 times 10 makes 10. Sorry, 1 times 10 makes 10, but 1 plus 10 makes 11. And then 2 times 5 makes 10, and 2 plus 5 makes 7. So those are the factors that we're going to use. So we're going to rewrite our function as y equals x plus 2 squared over x plus 2 times x plus 5, because 5 times 2 multiplies to 10, and 5 plus 2 is 7. And so a vertical asymptote is something that makes a 0 in the denominator. However, since we have 2 factors in the denominator, notice that if I have x plus 2 squared, I can divide both the numerator and the denominator by x plus 2. And so that leaves us with x plus 2 over x plus 5 which means that we actually only have one factor in our denominator. So if I take and set x plus 5 equal to 0, and then solve for x, that tells us that our vertical asymptote is at x equals negative 5. Okay, so remember that when I cancel something, that creates a hole. So that means that this does not have a vertical asymptote at negative 2 where it canceled. Instead, it has a hole there. But since the question was only asking for vertical asymptotes, we're only identifying that x equals negative 5. For number 4, we're going to use equations to complete the sentence. The graph of y equals negative 4x plus 5 has vertical asymptote at blank and a horizontal asymptote at blank. So let's look at the factors of this expression. So if I have negative 4x plus 5, I cannot factor anything out of that numerator. However, 5x plus 15, each term has a common factor of 5. And so that's going to leave us with 5 times x plus 3. So 5 times x makes 5x, 5 times 3 makes 15. So looking at the factored form, our vertical asymptote is going to occur at the 0 of our denominator. So since 5 does not have a variable, that's not going to give us an asymptote because it can't ever be 0. It's just 5. However, x plus 3 is going to be 0 when x is negative 3. So that means that the vertical asymptote is at x equals negative 3. For the horizontal asymptote, remember that we're comparing the degrees of the numerator to the degree of the denominator. So looking at our original expression, the highest power in our numerator is 1, and the highest power in our denominator is also 1. Because they're equal, that means that the vertical asymptote is going to occur at the fraction of the leading coefficients. So that means it's going to occur at y equals negative 4/5, because the leading coefficient of the numerator is negative 4, and the leading coefficient of the denominator is 5. Question 5, we're looking at just horizontal asymptotes. And so remember that we have essentially 3 different cases. So we have where the numerator degrees is less than the degree of the denominator. In that case, the horizontal asymptote's at y equals 0. Or the degree of the numerator can be greater than the degree of the denominator. In that case, there is no horizontal asymptote. And then if they were equal, what we saw in the last problem is that it's the ratio of the leading coefficients. And so if I look at each of these, all of these have a degree of 1 for the numerator and the denominator. So notice that even though they're not necessarily in standard form, each of them have the same degree. So all of these are of this type because I have a linear over a linear, a linear over a linear, and so on for each of them. So what I'm looking for is on that linear term, what is the coefficient? And so the ratio of those coefficients is the horizontal asymptote. So I have 1 over 1 for the first one, which means that y equals 1 is the horizontal asymptote for 5a. For 5b, my first leading coefficient in the numerator is 1, and then the leading coefficient in the denominator is negative 5. So negative 1/5 is the horizontal asymptote for 5b. For 5c, the numerator has a coefficient on the x term of positive 4, and the denominator has a coefficient on the x term of negative 1. So that means that the answer for 5C is -4. And then finally, the term with x for the last rational function is -14. And in the denominator, it's a +2. So that means that the horizontal asymptote for 5D is -7. Even though I almost wrote -6, it's -7. Huh. Okay, so for the last problem, we're graphing. And so when we're graphing, we want to find the vertical asymptote and the horizontal asymptote. And so it looks like this doesn't have a hole. And then we're going to find the table of values. So the vertical asymptote is using the properties that we just looked at. And so notice that the degree of the numerator is 1, which is the same as the degree of the denominator. And so because the degrees are equal, we're looking at the leading coefficient. And so the leading coefficient of the numerator is a 2. So y equals 2 over the leading coefficient of the denominator is a 1. So y equals 2 over 1 means that our answer here is y equals 2. Oops, I wrote that in the wrong spot. So that's for the horizontal asymptote, not for the vertical asymptote. Let me move all that down. I apologize for not reading. Okay, so for the vertical asymptote, we're looking at the denominator. And so our denominator is x plus 2. If we take x plus 2 and set it equal to 0, that means that -2 is going to be the 0 of that. So our vertical asymptote is that x equals -2. So let's draw those in on our graph. So at -2, we have a vertical asymptote. So we're going to draw a vertical line through -2. At +2, we have a horizontal asymptote. So we're going to draw a horizontal line through +2. Remember that when we draw or create our table, we're looking for 2 values to the left of our vertical asymptote and 2 values to the right of our vertical asymptote. And so since our vertical asymptote is at -2, we want to pick values like -3 and -4 on the left and -1 and 0 on the right. So when we're picking these values, we're really just picking something on either side of the vertical asymptote so we can see if it's going to be in one of these 4 quadrants between the 2 asymptotes. So we take these values and we plug them into our equation. So we're going to evaluate f of -4, which means we're going to plug 2 times -4 minus 1. So 2 times -1 over -4 plus 2. So that's going to give us -8 minus 1, so -9 over -2. So that's going to give us about +4.5. Then we're going to find f of -3. So that's going to give us 2 times -3 minus 1 over -3 plus 2. So 2 times -3 is -6, minus 1 is -7. -3 plus 2 is -1. So that means that's going to have a value of +7. For -4 is +4.5. So x is -4, y is 4.5. And then for -3, it's 7. So let's just kind of go up here for that value. So that means that this graph is going to look like that on that side of the vertical asymptote. And then we still need to plug in -1 and 0. So f of -1 is 2 times -1 minus 1 over -1 plus 2. So that's going to be -3 over +1. So that's going to be -3. And then when we plug in 0, 2 times 0 minus 1 over 0 plus 2 is negative 1 over positive 2, so negative 1/2. So for the other section of our graph, we're going to plot the points negative 1 and then negative 3, and then 0, negative 1/2. So that means that our graph will look like this on this side going through those 2 points. So those are all of the concepts that will be tested on this quiz. So again, make sure that you know how to write an equation for inverse variation, that you understand how transformations will affect the equation of the graph of a reciprocal function, that you know how to identify vertical asymptotes and horizontal asymptotes, and that you know how to graph a function by finding vertical asymptotes, horizontal asymptotes, and then using a table of 4 values.